Hello, geometry, and welcome to lesson 3 for classification of rigid motions. Here's where we're going to kind of put our reflections, translations, and rotations all together in one lesson. Okay. Now let's just recall that to be a rigid motion, you must do two things. Number one, you must preserve length. So it preserves. Number one, length. Which is the size of the figure, right? The side lengths. And number two, angle measure. An angle measure is what controls the shape. And again, if you preserve those two things, your pre-image and your image should be the same. We call them congruent, right? Same size, same shape. All right, so it says that the composition of two or more rigid motions is going to be a rigid motion. So if you do any combination of translations, reflections, rotations, from a pre-image to the final image, you are going to have a rigid motion. All right, everything's good. So here it looks like from here, they did a reflection across this line in between here, and then they rotated, right? That would be a rigid motion. All right, so it says write a paragraph proof of theorem 3.3. So again, it says, given that T and S are rigid motions, prove that composition of S and T is a rigid motion. All right. So we're going to do something very basic here. So please follow along. So we're going to start with T. All right. Because remember, when you do a rigid motion, or not a rigid motion, a composition, you go backwards. So let's start with T. All right. So we want to make sure that PQ is equal to P prime Q prime once it goes through T. And if you notice here, it looks like PQ and P prime Q prime did stay congruent. All right. The second thing is we got to make sure that the angles remain the same. So angle PQR has to be equal to the measure of angle P prime Q prime R prime. And if I look here, it looks like they are the same. So these angles look the same. Okay, now let's take a look at S. So now for S, now we're focused on the primes to the double primes. So again, it looks like P prime Q prime remained equal to P double prime Q double prime. So again, it looks like P prime Q prime is equal to or congruent to P double prime Q double prime. And it looks like the measure of angle P prime Q prime R prime is the same as the measure of angle P double prime Q double prime R double prime. So again, this angle and this angle are the same. And again, it's because T is a rigid motion, so it preserves length and angle measure. And S is a rigid motion, so it preserves length and angle measure. So then we're going to say by the transitive property, we're going to combine this PQ equals P prime Q prime and P prime Q prime equals P double prime Q double prime. We now know that PQ is equal to P double prime Q double prime. And do the same thing with the angle measures, and the measure of angle PQR is equal to the measure of angle P double prime Q double prime R double prime. So so S and T, a composition of S and T, I guess it's called S composed with T, is a rigid motion. And again, it's because it preserved side length and angle measure. Good deal. All right, so we should have confidence that if we mix two rigid motions, the result will be a rigid motion as well. All right, so let's do one. Is there a rigid motion that maps triangle ABC to triangle A prime, B prime, C prime? So first off, let's go with the definition of a rigid motion. Let's look at the side length. So AB. Is it equal to A prime, B prime? I would say yes. BC. Is it equal to B prime, C prime? I would say yes. And then AC. Is it equal to A prime C prime? I would say yes. So it preserves side length. What about the angle measure? Measure of angle A. Does it look the same as the measure of angle A prime? Yes. Measure of angle B. Does it look the same as the measure of angle B prime? I would say yes. And then the measure of angle C. Does it look the same as the measure of angle C prime? I would say yes. So therefore, it preserves angle measure. So yes, there is going to be a ridge of motion. All right, part B. It says, okay, does a reflection, translation, or rotation map triangle ABC onto triangle A prime, B prime, C prime? So it's looking for a single transformation. Well, if I do a reflection, I believe I could reflect it. No, I can't reflect it because it's too high. They're not straight across from each other. There's no diagonal line I can do it across either. So no, there's no reflection. What about translation? Well, A is pointing to the left and A prime is pointing to the right. No, I cannot just slide this figure and map it on there. And then rotations, I mean, if I go 180 degrees, I think that A is going to then be on top. So it would be down bottom. So there is not a single transformation. Okay, so if there's not a single transformator, what about a composition of transformations, right? So let's take a look at this idea of composition. So what could I do, right, with this composition of transformations? Well, if I look here, right, I think I talked about doing a reflection, but the idea that it was too high. Well, what if we could reflect it so that triangle ABC is straight above this triangle A prime, B prime, C prime? So what that would mean is I would need B prime to go here. I would need C prime to be here. And I would need A prime to be 2 away from C prime, right? This is where I would need the middleman, if you will, the middleman figure to go. So can I come up with the line of reflection that I could reflect triangle ABC across? Well, yes, I can, right? If I look here, right, if I connect C to C prime, 1, 2, 3, 4, this would be the midpoint right there. If I connect B to B prime again, 1, 2, 3, 4, this would be the midpoint. And if I connect those two, let's do it in blue. So here's this point and here's this point. Connect them. That would be the line of reflection. That would take this across to A prime, B prime, C prime, this red figure up here. This is the line x equals -1. So that is your first transformation. You're going to do a reflection across the line x equals -1. So then once you're here, let me change it to purple. Now once you're here, you need to slide down, right? A prime going to this A prime, 1, 2, 3, 4, 5. We need to go down 5. Same thing with C to C prime and this B to B prime. We need to go down 5. So the second is we're going to do a translation, but in only one direction. We're going to go 0 in the x direction, but down 5 in the right. And these are two transformations that'll map ABC, sorry about that purple, to the final A prime, B prime, C prime, this one down here. Okay? So to write this as a composition, I'm going to put in parentheses, again, it's right to left. So I'm going to put the translation here first, but we do that second. Compose with a reflection across the line x equals -1 of triangle ABC, and that should equal triangle A prime, B prime, C prime. So again, sorry that I ran out of room. This should go after the equal sign up there. And there we go. This is what we call a glide reflection, if you look down here. So a glide reflection is a composition involving a reflection first, followed by a translation second, but typically this translation is parallel to the line of reflection. called a guide reflection. Not a big deal, but something to know. Awesome. Okay, so there's our first video for lesson 3-4. Second video is coming right up.